Okay, let's talk about this definition. The area under a curve as a definite integral. It says if y equals f of x is non-negative and integrable over a closed interval from a to b, then the area under the curve y equals f of x over a to b is the integral of f from a to b, or in the definition as given below. So what is this trying to say? Well, let's take a look at an example. Let's say that we want to find the area under the curve. We'll use y equals x as our equation, and let's say we want to go from 0 to 6. Okay, so according to that definition, we need to write the integral. The integral from a to b, so 0 to 6, of our function x dx. And how do we go about finding it? Well, the first thing we need to do is we need to figure out, what does this look like? Well, it actually is a triangle. Okay, looks like I need to move just a smidge here. Give me a second. Adjust a little bit more. Let's just hold this down. That should work better. Here we go. Alrighty there. If you take a look, this is a generic picture of the equation y equals x. Okay, it goes through the origin. Okay, and they put an arbitrary point B. We're going to do this a little differently. We're going to change this to a 6, which makes that have a height of 6 since y equals x. So first we draw the picture. So step 1, draw a picture. Okay. Then look it over really good and see if we know any formulas. Okay, I asked that question because what is that? Well, of course, that's a triangle. And the area of a triangle is 1/2 the base times the height. So we take a look at our picture and we take a look at what we have. I'm just going to draw a sketch right here. So I have my graph, here's my equation, here it is. I know that this is 6, and because of that, I know this has a length of 6, and this has a height of 6. I can find the area by taking 1/2 the base, which is 6, times the height, which is 6. 6 times 6 is 36, and half of that is 18. I have just evaluated the integral using information that I already know and a formula that I know already. Well, let's take a look at another example. This is actually problem number 15 on page 353. That's page 353. It says find the integral from -2 to 4 of x over 2 plus 3 dx. Well, if I rewrite that, that's just the equation y equals 1/2 x plus 3. And over here, I've drawn a picture of that. So I have my intercept at 3. I went up 1 and over 2, up 1 and over 2. I went down 1 and over 2, so I could get to my boundaries of -2 and 4. I happen to recognize that's a trapezoid, and the area of a trapezoid is 1/2 base 1 plus base 2 times h. In order to make that work, I kind of have to turn my trapezoid this way. Here's base 1 and base 2. Going back to where we were. So now I have, well, base 1 is the value of the function at -2, and base 2 is the value of the function at 4, and the difference between those happens to be the height. Here's my height. Okay, so I do the math. I have 1/2, 2 plus 5, and then I have a 6, so I did my math, and I got an area of 21. So I would say the integral from -2 to 4 of x over 2 plus 3 is 21. Because I know it's a trapezoid, I can use the trapezoid formula to solve it. Let's take a look at number 17. Number 17 says we want to find the integral from -3 to +3 of the square root of 9 minus x squared dx. What is that? Well, I hope you all remember that's nothing more than half a circle. It's the top half of the circle since we have the invisible plus sign in front of it. We're going from -3 to +3. Well, that would simply be 1/2 pi r squared. Well, r is 3, so that would be 9/2 pi. Final answer. Let's look at another one. How about number 19? It says we want to find the integral from -2 to 1 of the absolute value of x dx. Now let's see what that looks like. If I draw a picture, absolute value does this. It says I want to go from -2 to 1. Well, I don't know about you, but I see a triangle over here and I see a triangle over there. Well, if this is 2, then this is 2. So this triangle has an area of 1/2 of 2 times 2. Plus this has an area of 1/2 of 1 times 1. So 2 times 2 is 4. Half of that is 2. 1 times 1 is 1. Half of that is 1/2. Sorry. So I have an area of 2 and 1/2. Oh, what happens in number 21? It says we want 2 minus the absolute value. So we have the integral from -1 to +1 of 2 minus the absolute value of x dx. Let's think about that a minute. What is that doing? I need some parentheses here too, by the way. Let's see, I want 2 minus that. So that means I'm going to start up here at 2, 1, 2, and the minus tells me I'm going to go down. So it looks like this. I'm going from -1 to +1. I don't think I'm in the right spot here. That should probably be this one. Should be here. Sorry, that is my bad. That should be 2 and -2. I want 1 to 1. So what does it look like? It looks like a rectangle on the bottom with a triangle on the top. Well, let's talk about that. Okay, the rectangle has a length of 1, 2 and a height of 1. So plus the triangle has a base of 2 and a height of 1. And we have to multiply that by 1/2, so I have a 2. 2 times 1 is 2. Half of that is 1. I see an area of 3. You see, by taking it apart and looking at it as parts of objects we already know, it makes finding the area much easier. All right, so what I would like for you to look at for this part of the lesson is page 353. Problems 16 to 26 even. Give those a shot. Let me know where you have issues, and I'll be happy to help you out.